Today I want to share with you a model that we develop in Galaxies that helps to see visually what is the benefit of having multiple diverse personalities rather than have few personalities in a group. So the model is pretty simple. It's using agent-based modeling. You can see it here. We are dealing with actually three types of personalities: head, heart, and wheel. Each one of those personalities has different behavior that he needs to maintain in order to feel confident. And if he doesn't maintain this behavior, he feels unconfident, and he's switching into a more aggressive behavior. Each one of them has repelling and attracting reaction to others. And what the model is doing is high level, define rules of appealing or rejection between those three personalities and apply it to 200 different agents and run it over time to see circle by circle or run by run how it actually impacts the team. So it will start with 200 random agents or people that have random personalities attached to them. I'll run it for a second just to show you how it looks like. So let's stop the run. So what you see here is actually 200 different people with three different personalities: head, heart, or wheel. And what the model will try to do, it will follow the rules that we will going to see in a second and try to adjust the random assigned people to the rules that define. So if something is repelling, it will try to replace it with someone that is actually attracting. So over time, what you're going to see is certain agent will change the personality, which actually depicts that someone left the group and someone else has been added to the group with random personality. If this random personality fit this model, it will stop change. But if this random personality will repel from other personalities, it will keep on replacing. Now, the rules is that it's going to replace an agent with different random personalities 9 times. 10 times is simply going to push away this agent out of the model. So instead of seeing an agent, we'll see an empty slot. So let's look at the rules before we are running it. And they're really far away from being complex. Let me go to the action. So there's a function that moves it, but in reality, the rules are extremely simple. Head and wheel will repel head, which means that if there are too many head and wheel around head, the head is going to be removed. Head is going to repel heart. So if there are too many head around the heart, it will be replaced. And last but not least, wheel can't stand too many wheels around him. So if there are more than four and more wheels around one wheel, it will be removed. And when I'm talking about 4 and 5 and 6, I'll run it for a second and I stop it. Every element has 8 neighbors around it. So when we say 4, it means that at least 4 agents around it should be the color that we defined, or at least 3, or at least 2, or at least 1. But it's always the 8 agent around a selected one. So what the model is going to do is going to go agent by agent and apply those rules, those simple rules. So let's run it with 3 personalities. You will see some changes in the model in the beginning. It will be some adjusting, but after a while adjusting will go away. The model reach an equilibrium and all the rules are actually being applied, so there are no movement in the group anymore up until this simulation will end. Pretty straightforward. No one left the group. Sometimes you'll see one or two guys leaving, but in this particular scenario no one left. We have some changes, and if you go to new display, it will show us the average of changes, which is very low, 0.22 actually, almost very few changes. Or we reach very few times more than 9. We didn't actually, because otherwise it will be 1. So that's what happened when you are running it in with 3 personalities. Very rigid group can survive. So we are running it for 200 cycles. It could be months, it could be days, it could be years. It really doesn't matter. But 200 cycles, it's running and it stays extremely stable. Some adjustment in the beginning, and that's all. Now we will try, so let's put it here as a reference. Now we will going to change it to 2 personalities. So what we are going to see now, just the wheel and the head. We will create a group of 200 people just with wheel and head, and we will apply the same rules. We are not going to do any change to the model, just run it with 2 personalities. And what do you think is going to happen? So I'm going to stop for a couple of seconds, let you figure out what you think is going to happen. Okay, if you have an idea, let's run the model and see what's happened. So you see randomness, then you see kind of segregation, and then in one point of time, very fast, in 2 or 3 steps, majority of the group element actually left. They left because the segregation reached a peak of repelling between personalities, and since there wasn't any third personalities to balance it, what we see is a very bad example or results, like look side by side, very bad results of what's going on to a group from longevity point of view when there are 3 personalities or 2 personalities. And I can pick 2 other personalities, it will look more or less the same. So that's all. Just want to show in a very visual way why it's so important to have different personalities in groups, and why if you didn't let the group naturally evolve, it will take care of by itself. If you design or engineered the group, you have to make sure that there is the right combination of personalities. Otherwise, you end up in that scenario. That's all. Hope that it's helpful. If you have any comments or questions, please write them down and I'll be happy to answer. Thank you for your time, and bye.